Hey, everybody, and welcome. Thanks for joining us today. My name is Joe Travellini. I'm a product manager on the Amazon ElastiCache team. And joining me is Calvin Peterson, a software engineer at Rokt. And I'm really excited to be talking about the general availability of data tiering for Amazon ElastiCache for Redis. During the session today, Calvin will review how Rokt uses ElastiCache and data tiering as part of their e-commerce marketing technology stack. So here's what we plan on going over today. I'll begin with a brief overview of AWS's database services and where ElastiCache fits in. I'll then introduce data tiering, starting with the basics. We'll go over pricing, how you can get started, and performance. I'll turn it over to Calvin in the middle of the session to share the cool things that they're doing at Rokt, and then wrap things up by going a level or two deeper on how data tiering works and how you can put it into practice. And we'll leave some time at the end to go over any questions you might have. Cool. So let's jump in. Again, first with a quick review of ElastiCache and where it fits in overall into the AWS database services landscape. Our philosophy at AWS, when it comes to database services, it's really to provide purpose-built solutions, meaning giving customers the right tool for the job that they're looking to tackle. In the database portfolio, there's everything from traditional relational databases, things like RDS and the cloud-native Aurora, to all varieties of non-relational stores for workloads that need things like document databases, time series, all the way to wide column and so on. ElastiCache is one of two of our in-memory services, which are designed to serve workloads that need the super low latency and high throughput performance that only memory can provide. ElastiCache itself comes in two flavors with two underlying engines to choose from, one for Memcached and another for Redis. Today, we're going to be focusing on ElastiCache for Redis and its new data tiering capability. And if I refer to simply ElastiCache as a shorthand, it's implied that I'm referring to ElastiCache for Redis in this session. Before getting into the details on data tiering, I do want to level set on ElastiCache for Redis for folks that might not be super familiar with it. Our aim is to make ElastiCache the best place to run Redis, anywhere, period. And as the name implies, ElastiCache for Redis is fully compatible with the open source distribution of Redis, which is a super popular in-memory key value store. It has a simple yet powerful API and blazing fast performance. Redis is consistently voted the most loved data store by developers, now for 5 years running in the annual Stack Overflow survey. ElastiCache is fully managed, meaning as a customer or a consumer, you don't need to deal with the complexities of keeping the lights on, so to speak. There's no hardware or infrastructure to maintain. You don't need to install or manage Redis software. There's no need to configure a custom monitoring solution. We handle all this undifferentiated heavy lifting for you. ElastiCache for Redis is also highly available. You can deploy in a clustered configuration with shards and replicas distributed across multiple availability zones. You can also access your ElastiCache clusters across different AWS regions using our global data store capability. And just recently, we launched support for application auto-scaling, so your clusters can scale in and out as your traffic demands change over time. One of the killer features for ElastiCache as an in-memory data store is its performance, offering microsecond latencies for reads and writes to data stored in memory. We'll talk a little bit more about performance of data tiering in just a little bit here. We also offer a number of security controls and compliance certifications, so you can be confident running Redis clusters in enterprise environments and for production workloads. So we provide things like network isolation controls, encryption, resource-based access control, and access control lists. ElastiCache is a HIPAA-eligible service and has achieved a number of compliances like ISO, SOC, PCI DSS, FedRAMP, and more. And finally, ElastiCache is scalable, giving you easy ways to scale your cluster up or down while remaining online. You can scale your capacity to serve reads using cross-AZ replicas and writes using data partitions called shards. ElastiCache clusters can grow up to 500 nodes in a single configuration. All right, so now I'm going to jump into the data tiering element of ElastiCache for Redis, which just became generally available at the end of November. So what is data tiering? It's the ability to expand the available storage capacity in your clusters by automatically and transparently moving data between memory and locally attached NVMe solid-state drives, or SSDs. So whenever the available memory capacity in your cluster is fully consumed, ElastiCache will begin to move items from memory to disk, effectively expanding the amount of cluster storage that's available from a capacity perspective. The way we choose which data to move from memory to disk is by using a least recently used, or LRU, algorithm. In other words, when you're using a cluster with data tiering, ElastiCache will monitor the last access time of every item that's stored. When memory fills up, it chooses the item that was accessed least recently, or in other words, the longest amount of time ago, and moves it from memory to disk. If your workload needs to retrieve an infrequently used item after it moves to disk, ElastiCache will first move it back to memory before servicing the request. So really what this boils down to is giving customers a new price performance option for their Redis workloads. SSDs have slightly higher latencies when compared to memory, but also cost significantly less. So if you have an application that can tolerate a small amount of additional latency every so often, the first time an infrequently accessed item is needed again, data tiering can provide compelling cost savings as your datasets grow. And again, we'll go over performance in more depth in just a minute here. The sweet spot for data tiering is for workloads where up to 20% of the dataset is hot or accessed regularly, and the other 80% of the data is warm or accessed infrequently. If you're running at full capacity utilization, meaning fully consuming available memory in your cluster, and in this case with data tiering, also fully consuming the storage on disk, you can save over 60% in your bill as compared to running fully in memory. To use data tiering, there are no application changes required. It's completely transparent to applications, and it's designed to have minimal performance impact with a focus on providing low latency. At launch, data tiering is supported when you're using the Graviton 2-based R6GD node type. On the right here is an example of the largest node size we offer with data tiering, the R6GD 16x large. Across memory and disk, the 16x large provides 2 terabytes of capacity. And again, if you use that 500 node configuration, you can now scale up to 1 petabyte of capacity in a single Redis cluster. Here's a quick comparison between the data tiering node offering and its closest counterpart, the R6G. The way I like to think about it, the difference is that the D in R6GD stands for disk. So from a hardware perspective, that's really the only difference between the two. Each data tiering node has about 4 times the disk capacity as it does memory. And this 4-to-1 ratio is where that 20% figure comes from that I just talked about. From a price perspective, data tiering nodes do cost more per hour relative to the R6G, the non-tiering counterpart, as they include the custom fully managed tiering software that ElastiCache is providing, and because they offer 4.8 times more total capacity than the R6Gs. When you think about pricing from a capacity perspective as opposed to the per node hour price, you can see that you're saving over 60%, with 0.6 of a cent per gigabyte hour when using data tiering compared to 1.6 cents per gigabyte hour when you're not using data tiering and running fully in memory. And to help you right-size your cluster footprint, we offer data tiering nodes in sizes ranging from X large with 125 gigabytes of capacity at the low end, all the way up to 16X large and 2 terabytes of capacity at the high end. So here's a summary of the specs for all the node sizes that we offer, from X large all the way up to 16X large. All this information is out on our public website, so I'm not going to walk through all the data in depth, but one thing I want to highlight here is that the effective price per gigabyte is consistent across node sizes, again, at just 0.6 of a cent per gigabyte per hour. Another thing I want to highlight, all these prices that you see here, they're using the US East 1 region's pricing, and they represent pricing for on-demand nodes. You can actually save up to an additional 55% over these prices if you're going to use reserved instances or reserved nodes. At the time of the launch and of this broadcast, we offer R6GD nodes for ElastiCache for Redis in 9 AWS regions, spread all across the globe. All right, so before turning things over to Calvin, I want to share a summary of some of the performance benchmarks we ran against clusters with data tiering. So the way we ran our benchmark, we used the open source Redis benchmark program. We executed it across 5 EC2 instances using 200 client connections, and we let the test bake in for continuously over a 2-week period. So from a cluster perspective, this was executed against a single node R6GD 2x large cluster. We loaded almost 400 million unique keys. Each key was comprised of a 16-byte string, and each value was a 500-byte string. We used a 4-to-1 read-to-write ratio, and we curated the workload such that 10% of accesses at any given time were guaranteed to fetch items stored on disk or SSD. And we did this because we wanted to assess the impact of when infrequently accessed items stored on SSD were needed again. And overall, what we found is the performance impact was minimal. So on the left here, you can see the command latencies, and we have them broken down by average, median, 90th, 95th, and 99th percentile. At P99, latency is just 1.4 milliseconds compared to 820 microseconds on average. The node was also able to sustain serving 240,000 transactions per second. So if you have an application with large capacity demands and it can tolerate this performance profile, data tiering might be a way for you to cost effectively scale as you grow. And on that note, I'm going to turn it over to Calvin to share how Rokt is using ElastiCache and data tiering to do just that.
Thanks, Joe. Hi, everyone. My name is Kelvin, and I'm a software engineer at Rokt. Rokt is a global leader in e-commerce technology powering the transaction moment. Rokt's mission is to make e-commerce smarter, faster, and better. Brands spend a lot of money getting customers to their site to select a product, but that's usually when the optimization stops. The e-commerce transaction moment is an engagement moment with a massive opportunity to deliver more relevance and value. So for the team I work on, the identity team, our main goal is to answer the question of who are our customers? And this is required for Rokt to optimize our customers' experience. Typically, the identity is a graph problem. When we set out to build an identity graph, we wanted to have a graph which we could run large-scale A/B tests, as well as the system we built needed to scale as Rokt grows. We wanted to be able to handle bulk deletes and bulk inserts, and we really needed low latency reads. After analyzing all the potential solutions, we opted to build our own bespoke solution using Apache Spark and a key value store. We decided to pick Redis because, well, it's a key value store and it fit our data model. It also supported an extreme write throughput, which is required for our deployments and A/B testing framework. It has low latency reads, which is needed for our strict SLAs for our real-time APIs. And read and writes are horizontally scalable. Because we're an AWS partner, it made the most sense to use ElastiCache. ElastiCache lets us have cross-AZ replication, which allows our Redis cluster to be HA, has global replication support, so data is available in all regions. It meets security standards with authentication, encryption in transit, and encryption at rest. And it allows Rokt to worry about our domain instead of solving infrastructure problems. So a bit about our application architecture. We have a Spark application which reads data from S3. That's used to do this initial graph build process. And this is a very large scale operation. We can scale out our cluster on EMR quite quickly, and it's a heavy operation. After that, we write an initial graph into Redis, which is why it's very important for our key value store to have extreme write throughput. And then we switch to an incremental mode where we keep our graph up to date using data from Kinesis. We upsert data into Redis and we append identities into S3. Because we're using global data store, data is replicated into secondary regions, and our real-time APIs, which a global API can read off global data store. So this is the cool part. Because we're on AWS, we can just spin up new infrastructure when we want to deploy a new graph. So what we do is we spin up a new EMR cluster, a new ElastiCache cluster. We deploy a new version of our graph, and then we can A/B test two graphs against each other. Our API will serve traffic from both Redis clusters. After we're finished A/B testing our graph, we can blow away the old infrastructure and we'll maintain some history on S3, and 100% of the traffic will shift to the new cluster. So Rokt's data is growing at a rapid rate. On our team, we're seeing significant growth in the amount of edges that we accumulate each month, from less than 1 billion last year to almost 2 billion this year. And that correlates to the number of nodes in our ElastiCache clusters that we need. So we've gone from about 50 last year to around 200 this year and growing. And during an A/B test, because we have separate infrastructure, that node count will double. So you can see spikes there. We also want to introduce additional data into our graph. We want to change our model, which will end up increasing the amount of data that we'll have to store in our cluster. So with ElastiCache data tiering, it will allow Rokt to trade off latency costs while allowing us to scale with our growing data requirements. We'll be able to save up to 62%, supporting the existing implementation. And it's also had a very minimal impact to our read-write access patterns. We've benchmarked our batch writing, which is the heaviest operation that we do. And we can see that the write throughput for memory and disk are almost identical. And data tiering kicks in as soon as memory is full. So least recently used items gets evicted onto disk. So what does this mean for us? We can reduce our costs, which will allow us to focus investments for R&D across different channels. And it allows us to work on bigger projects for our clients and partners. It's also one less thing to worry about as our data grows. Back to you, Joe.
Awesome. Thanks, Calvin. It's always really great to see real-world examples of how Redis can serve global web-scale applications with massive growth and stressful performance demands, like the use case you just went over. So really glad to hear about how data tiering for ElastiCache is helping your workload and your business grow, and look forward to seeing many more customer success stories in the future here. So before wrapping things up in the session, I want to spend a little bit more time looking at how data tiering works again, maybe a level or two deeper. I'll then review how you can monitor your data tiering clusters using Amazon CloudWatch, and then finish up highlighting some of the limitations that exist with our initial launch here. Okay, so earlier I was talking about how ElastiCache is going to track the last access time of every item it stores when using data tiering. So to do this, we need to store some additional telemetry, and we're able to do so using an efficient, low overhead 16 bytes per Redis key. I mentioned that as it's something you want to keep in mind when you're planning your clusters, since each key will consume that additional extra 16 bytes of space. In terms of how the LRU algorithm functions, it works atomically at the item level, meaning, basically an all or nothing basis. So if you have a more complex data structure, something like a hash or a sorted set, any read or write to that item will constitute an access. So if you have a large hash you haven't touched in a while, more than likely it's going to move in its entirety from memory to disk. But in the future, if you have to retrieve any portion of it, ElastiCache will move all of its content back from disk into memory. This behavior is something that can have performance implications, so we do recommend keeping an eye out for additional latency if you have a large, complex data structure that you expect to age off to the SSD tier, but then subsequently need to access again sometime in the future. And again, that penalty is really on the first time it's accessed, because once it comes back to memory, it'll then become subject to LRU once again. Another thing to keep in mind is that the keys themselves are always stored in memory. So it's the values that ElastiCache will tier to disk. We do that to provide consistent performance for lookups and other metadata operations on keys. And finally, we perform asynchronous I/O between the Redis engine and the tiering engine in order to optimize for latency overall. So when an item on SSD needs to be accessed, we asynchronously move it from disk back to memory. And in doing so, we're not blocking the main thread, and that allows for concurrent client access to the cluster with minimal overall disruption to performance. So hopefully at this point, you're thinking about how am I going to get started using data tiering and which workloads you can kick the tires with. One thing we recommend doing in your testing, and of course, when you're operating in production, is monitoring your metrics in CloudWatch. So with the launch of data tiering here, we've updated the metrics that are available for ElastiCache in a couple of different ways. First, we introduced 4 new metrics that are specific to clusters with data tiering. The names here, they're pretty self-explanatory. The number of items written to disk, number of items read from disk, number of bytes written to disk, and number of bytes read from disk. These metrics give you a sense of how much I/O your workload is issuing against the SSD tier. We also added a new metric dimension called tier to 2 pre-existing metrics: current items, which tells you how many items are in your cluster, and bytes used for cache, which tells you the size of data consumed in the cluster. Now, this tier metric dimension is completely optional. If you don't specify it, simply query the metric, like, for example, current items. It will give you the total irrespective of tier, just like it does today. However, if you want to filter or break down how many of your items and or the size of those items by which tier they're on, memory or SSD, you can now do that. And again, that tier dimension is only valid on these metrics for clusters when using data tiering. So here's an example CloudWatch dashboard that shows these new metrics. You can see up on the top row, those 2 graphs, the new tier metric dimension and how the tally, memory plus disk adds up to the total. Now, let's say you're looking at the metric on the bottom right, specifically not the number of items read from disk. In the event you are experiencing high client-side latency, you might choose to inspect this metric's value. If you deem the metric to be too high, for example, you can compare it to the sum of all commands being issued against the cluster using CloudWatch. CloudWatch has a feature called metric math, which allows you to create your own formulas and synthesize metrics together. So we offer 2 other metrics, get type commands and set type commands. You can add those 2 up to see the total number of commands being issued against your cluster. You can compare it to this number of items read from disk. If the proportion is too high, you might choose to rescale your cluster. You can scale it up using larger node sizes, scale it out, add shards and replicas. That way you have additional memory capacity to store your hot data, and you reduce the amount of I/O going to disk. So last but not least, just want to highlight some of the limitations that exist with the initial launch here, so you can just be aware for planning purposes. For starters, large item values specifically ones exceeding 128 megabytes in size, are not eligible for data tiering. So those values are always going to remain in memory, and ElastiCache will never move them to SSD. Next, the set of max memory policies that govern key eviction are limited to the following three. No eviction, which basically turns off any sort of eviction, or one of the two LRU-based policies, all keys LRU and volatile LRU. Now, just want to call out a nuance that, there's two different types of LRU in the fray here now with the data tiering launch. There's the LRU that happens with the data tiering engine, and then there's the LRU that happens for key eviction overall. So the first type, the tiering LRU, that controls the behavior of when items are moved from memory to SSD when memory fills up. And that's not configurable. That's how data tiering works, and that's fully managed by ElastiCache. The max memory policy, which does now have a slightly misleading name, that controls the behavior when all available capacity, memory and SSD, is fully consumed. And you can select, one of these three policies for your cluster. And then finally, some of our cluster management features aren't yet supported with R6GD. Things like online migration of a self-managed Redis cluster directly into an ElastiCache cluster with data tiering, that's not supported. Instead, you can migrate into a non-tiering cluster, create a backup, and restore that backup into a new data tiering cluster. Similarly, online rescaling a cluster from a node type other than R6GD into one that uses data tiering is not supported at launch. So again, we would recommend restoring from a backup if you're looking to migrate over an existing workload. And while auto-scaling is not yet supported with R6GD, manually rescaling up or down is supported. All right, so that basically covers everything we wanted to go over today. Just wanted to summarize. Obviously, super excited to make clusters with data tiering available to our customers. And again, this is all about cost-effectively scaling to large amounts of capacity. It's ideal for applications that access up to 20% of their overall data set regularly, completely transparent to applications, no changes are required, designed to provide minimal performance impact, and it's available today in 9 AWS regions all across the globe. So thanks everybody for your attendance here. We'd be happy to answer any questions you might have.